Aloha, Richard Halverson here, and today I'm going to talk about dictionaries out of chapter 14. So let me share my screen. And we are right about here. I'm going to click on dictionaries here, and it looks like there's a pretty lengthy quiz here that we'll be able to have fun with. All right, so we have already covered tuples. You should have covered tuples and sets and lists. And these all are various ways of storing data in ways that are convenient to the types of problems that we solve in programming. And a dictionary is the most complex. There's actually key value pairs, as they say. So with each item in the dictionary, there's a key and a value, and you reference the different items in the dictionary by their key. And so this is a good video to watch here. It explains how you access it. You notice here in a list is just a single list of items, and they just have one value. It's just a value attribute. And there's different properties. They can be sorted. You can change them. It's immutable and it's mutable and all that. And you can refer to the different items in the list by an index. Now a dictionary adds a key value to it. So instead of referencing it by an index, you reference it by a key value. And so it's a little bit more difficult to grab any old item out of a dictionary, because you got to have a way of knowing a item that you have to know the key value of an item to be able to do that. So there's tricky ways to get around that and so on. But so here, for example, you see that you can't just say the zeroth item in a dictionary, because it doesn't know what that is. You have to say the zeroth item happens to be, well, there's an item in here, 3214, and that's Jones, and that's how you would refer to it. All right, so when we store a dictionary in the memory, it looks kind of like this, where each item has a key value and a key and a value, and that whole thing is called an item. And here's an example: social security numbers, maybe for some people here. When you create a dictionary, you do it like this. You use the curly braces, and you put in pairs. This is the key. This is the key, and this is the value. It's not right. And so the first item is this key value, and it corresponds to the value John. So something like this is how you would create an empty dictionary, like that. Or you can do it like this. Keep in mind that when you do this, you're creating a dictionary and you're not creating a set, because you also refer to when you're talking about dictionaries or sets, you also use the curly braces. So to add an item to the dictionary, you have a dictionary name, and you say that the dictionary for a particular key value, and if it's a key value that's not in there yet, then this will create a new item in the dictionary with this new key and its associated value. If the key is already in the dictionary, then this will just replace. This is just like writing over what the old value was for that particular key. So here we're showing some Python here, where we create a dictionary called students, and we're assigning. There's three of them, two of them, and here we're adding one with named Susan, And so now when we want to display out that new one, it's displayed this way. Here we are rewriting this first one. We're adding a last name. As you see, we're changing John to John Smith. And so that's why the display is like that. Here, you're asking for a student whose key value does not exist in the dictionary. So it flags an error there. When you delete items from the dictionary, you refer to the dictionary item by its key, and you put the DEL keyword in front of it to delete it. So for example, this is how you delete a student record. And you can loop using a for loop through a dictionary. And what this does is you have this dictionary called students. And so you can do for each key in students, and then you can go ahead and loop through it, and you're able to reference each item in the dictionary by its key value. So this shows you're looping through these students, each key value, and this is how you refer to the value part for that particular key. And so this is what's displayed. There's a length function, and it tells you how many items are in the dictionary. You can test to see whether a key is in the dictionary by asking if a key value is in the dictionary. This is an expression which is going to evaluate to either true or false. And you can test to see if two dictionaries are the same using the double equal operator, or if they're not the same, using the exclamation point equal operator. And you see that the order of the items in the dictionary doesn't matter. So we have one dictionary here that's where red 41 and blue 3, and a second dictionary where the two items are in reverse order, presumably by this description, but they are still equal. And you cannot use any of these operators to compare dictionaries because it doesn't make sense. Okay, so there's some other methods here, some other dictionary methods that are available, and this will return the dictionary keys as a collection of keys. It's like a set of keys. This will return all the values, like a set of values. This will return all the items, which return the pairs, the key value pairs. Clear will delete all the entries of the dictionary. Get will get a particular value for a key, get the value part, and you give it the key. This will removes an item for the key and returns the value. So this just returns the value. This actually pops off the item. This actually removes the item. It appears. Removes the item. Get doesn't seem to remove the item. This returns a randomly selected key value pair as a tuple and removes the selected item. All right, so those are some methods. There's some other methods too that we're going to encounter. All right, so you should go through this, and let me just get right to the quizzes. All right, so let's look at the first quiz. These are just dumb quizzes. They don't start getting more difficult until like around 10 or 11 or 12 or so, but we'll just buzz through these. Okay, write a statement that associates D with an empty dictionary. I wonder if I can open up, so go like this and go back to 4. Can I have two two books open, two screens. I've never been able to figure out if I could do this. All right, we are back here, chapter 14, and we're doing chapter 14.6. So with this question, we are simply trying to write a statement that defines a new dictionary, sets D to be an empty dictionary, defines a new dictionary. That would be just something like this. This creates an empty dictionary. This associates the word students with an empty dictionary, or you can do it this way too. So that would be, that's likely the answer to that one. And you use D, not students. Okay, write a statement that associates D with a one-entry dictionary that maps answer into the integer value of 42. Well, that's, so you have a dictionary called D, and it's going to be something. It's going to be something, and it's going to be something, comma something, and it maps this into this. Well, so what that means is that this is the key. It maps this key into this value. So the first one is the key. So the first one would be this. And the second one would be simply the value. You don't need to put this in parentheses. And in fact, you can try putting it in parentheses, but something like that. That's what the answer is. So here we're just defining a new value. The third one refers to D, write an expression that is the value to which the dictionary maps the key maps this. So here we're just writing an expression, and what we want this expression to evaluate to is the value that's associated with this key in this dictionary D. So that's just simply D, and then you recall how we refer to it as D. D is a dictionary, and then we can put these braces here, or these square brackets, and the key, you put the key inside there, and then this will evaluate to should be like this. So that's an expression. This is not even a valid statement in Python, because it's just an expression sitting there. Usually you see expressions on the right-hand side of an assignment statement, but you make this bigger. So that's likely the answer. So that's all they're asking for here. So what's number? We have a dictionary D, and we're changing the value mapped to this. We're changing the value, whatever it is, we're changing it to this. So that's just an assignment statement. D of Monty is equal to Python. So D of, we're reassigning this value. Presumably this was assigned something else higher up in the program, higher up. And now we're just reassigning it to this value. So that's all they're asking for there. Here in 5, D refers to a dictionary and that X has been defined. So we have a D, we've got a D, for which X has been defined. So I'm okay, X has been defined, okay. So it's not that X, it's not that quote X is the key. X is a variable, and it's been defined earlier. So X is a variable defined earlier, and we're going to use it like a key. We're going to use the value of X, whatever that value is, as the key into D. So this looks more like that's just the value X, and we want to delete the dictionary entry whose key is equal to the value that's associated with X. So the key is the value that's in there, and we want to delete that dictionary entry. So that would just be probably something like this. Delete the dictionary item whose key value is whatever X is. You can try that. All right, assume we got a variable, Nobel Peace Prizes, that is associated with a dictionary. And what this dictionary does is it maps the years to the winners of the Nobel Peace Prize. And let's say that this, so we have a dictionary called Nobel Peace Prizes, and that's equal to, oh no, okay, so got a dictionary called that, Nobel Peace Prizes, and it's defined all the way up to year 2005, and we're going to add a new one for 2006. Now so it's the key value, 2006. This 2006 is not in quotes, so I would just say it's 2006. What am I doing here? 2006. I would say it's that, and basically we're entering in this new value, which is these guys. So Nobel Peace Prize winners 2006. Oh, these guys. Muhammad Yunus and Greenman Bank. Bank. Really? Okay. So anyway, that's the answer to that. I'm quite sure. What's number 7? What's 7? Assume there is a variable called album artists that is associated with a dictionary that maps albums to performing artists. Okay, so we've got album, and write a statement that inserts this key value pair, live it out metric. So there's a album called Live It Out, and the group is called metric. Metric, live it out. Live It Out. It's an album by Metric. Well, I guess I didn't know that. So equals. So we've got an album, and it's called Live It Out. And the musicians, the performing artists are called metric. So that's probably the answer to that one. Try that. We got a novel. Most recent novel. Copy this, put it down here. Maps the names of novelists to their most recently published novels. So it's the names of novelists, okay, the name, and we're talking about Harry Potter novels, and the artist. So I'm going to do, this is a artist in there is equal to some novel, recently published novel. Okay, so I think the novelist, the novellist, and it's going to be equal to replaces, okay, so whatever it was, presumably before this, somehow it was set equal to that, I guess she's come out with a newer one at the time of this was created, and it would be that. So this, copy this and put it there, and that assigns this value to this key in this dictionary. Okay, that should work. What's question 9? Given a variable U.S. cabinet that is associated with a dictionary that maps department names to department heads. Okay, so we've got a dictionary here called U.S. cabinet, and it's going to replace the key is Justice Department. So the key is Justice Department. And these look like President George W. Bush's Justice Department, because it used to be Alberto Gonzalez, and then it changed to, I don't know what this guy's name is, Mike Mukasey. Mike Mukasey. Mukasey. Am I spelling it right? Mukasey, I think I'm not spelling it right. Mukasey. Michael Mukasey. I think it's Mukasey. Anyway, so anyway, that was he was the Justice Department guy after Alberto. All right. So anyway, so then you'd say equals this guy. So you'd put that there. Try that. All right. Hello. Okay. Got everything. Everything's fine. Okay. We have a variable called planet distances associated with a dictionary that maps planet names to planetary distances from the sun. Write a statement that deletes the entry for Pluto. All right, I guess this Pluto's not a planet thing. So I guess Pluto's not a planet. So we wanna cancel Pluto here. And the way we do that is is Pluto a planet? Is Pluto a planet? Pluto is still not an official planet. Soon after Pluto was discovered, well, I don't know. I don't really know. I'm not an astronomer. I'm not into that. But there's something to do with it's maybe it's just a big mass of gas or something. I don't know. Anyway, that's fine. What's next? Where are we now? We are on. Okay. Given a variable unproved conjectures that is associated with a dictionary that maps the common names of mathematical conjectures to the years when the conjectures were made. Write a statement that deletes the entry for Fermat's last theorem. I don't know. Fermat's last theorem. I remember that. Oh! I remember that. Yeah. So his last theorem, he made a bunch of theorems, proved a bunch of theorems, and his last one was something to do with something, but he never proved it. What was Fermat's last theorem? Fermat's last theorem. Oh, that states there's no three positive integers, A, B, and C, that satisfy A to some power plus B to some power equals C to some power. Okay. Apparently, now, so that was his last theorem, but I guess he never proved it. And so, you know, you can't, the way you disprove it is you'd actually find an A, B, and a C, where when you raise them to some power, it equals, it's got to be greater than 2, because if it's to the first power, of course it works. 3 to the first power plus 4, but it's got to be if there's an n greater than 2. Anyway, so it's unproven conjecture. So I would say, and we're deleting. Remember, we're deleting, and it's about this guy Fermat. So it's this. Yeah, this is this would be what the deletes the entry for that. So try that. All right, now it gets to be harder. Given a dictionary D and a list, I'm gonna okay, I'm gonna end this video now, and I'm gonna start up a new one right up again, because as a lot of you, I think, have gotten everything up to this point. But starting at question 12, it gets to be hard, because the wording of the questions is not clear, and we're writing algorithms now. We're not just writing statements or expressions. So I will stop this and start the next video in just a moment. Thanks for watching.